Hi everyone, this is Tim, your Block 3 lecture instructor, and I wanted to do a voiceover for your math packet. This is practice math problems that we will be doing or covering for Block 3 MedSurg. These specific questions will not be on your test, but the ones that are like this will be on your test. I figured if I do a voiceover and kind of explain a couple things, this math packet actually came from your book. For those of you who are wondering what book that is, it is the Henke's Med Math book by Susan Buchholz, and it is the 8th edition. I think most of you, other than the paramedics, probably got this in Block 1, but this is where that came from. So if you're really looking for like more examples or how I came up with the answers or what I was expecting, or I'm going to explain a couple things about what the book does that we do not do, so that way you're not so confused. So, but I figure if I go through a couple of them, at least you have an idea of what to do. I will tell you what I want to do is give you a heads up in the sense of I do math in a very basic sense. Dimensional analysis, I can't really wrap my mind around it, so I can't really teach it real well. The book does a pretty good job of it, so for those of you who think that way, let the book actually help you. For those of you who just really want basic math and a formula, this is what I actually do. So I would actually do what you want divided by what you have, which is basically what the pharmacy sent, right? What you want is the doctor says, okay, I want you to give 500 milligrams of amoxicillin every 8 hours. What the pharmacy sends you, whether it's pill, whether it's fluid, whether it's a bucket of fluid, whether it's a bag full of granules, it doesn't really matter. What the order was is what the doctor wants you to give. What the pharmacy actually sends you, it's a matter of you figuring out the calculation in order to make sure that they actually match each other. So if you take what you want divided by what you have and multiply it by the volume, it'll actually give you the answer. That's pretty much the math in the simplest form, and that's how I do it. So I'll go through a couple examples. So the first example is, let's see if I can find it. I think I lost it. Oh, here we go. So the first question for page 264 is asking you that heparin sodium of 800 units per hour IV in the infusion pump standard solution is 25,000 units in a 250 ml bag of D5W. So basically, you're going to take what you want, or the order, divided by what you actually have, and multiply it by the volume. So let's see here, 800 divided by 25,000, 250 mLs is your volume. And if I can find my phone, we have, let's see here. So 800 divided by 25,000 times 250 is going to be 8 mLs per hour. And according to the answer, it is 8 mils per hour. So that's, again, what you have ordered divided by what you have as far as what the pharmacy sent you or your supply, and multiplied by the volume gives you the answer. So it's 8 mLs per hour. Because I didn't actually give you a drip factor, whether it's 20, 10, 15, or 60, you know that this is going to be an infusion pump. I actually have a machine that I put this bag into in the tubing, programmed for what I wanted to do, punch in the numbers, and it actually came up as an even number of 8 mLs per hour. A pump can actually do tenths of a drip. So if this would have come out to let's say 7.5, you don't do your rounding because of the fact that the machine can handle 7.5. I'm not physically looking at a drip going, okay, 1, 2, 3, 4, 5 drips. I'm really just letting the machine do it. So it can do tenths of a drip. A drip factor of whether it's 10, 20, 15, 50, 60, it doesn't really matter. If I give you an actual drip factor, that tells you that it's actually based on gravity. I can't see a fractionized drip. I visually just can't do it. So if I actually see a drip, it's a drip. It's a drip, it's a drip, it's a drip. There is no half drip, quarter drip, it's truly a drip. So if you get a drip factor, it's telling you that it's based on gravity. If you get an answer of 7.5, you're going to round up to 8 because I can't see that half drip. So if there is no drip factor, it's a machine to the tenths. If there is no machine, it's a drip factor. It is actually going to be rounded up or down based on that tenth of a number because I can't see the drip. All right, so for number 2, let's see here, cyclovir 500 milligrams and 100 mLs of D5W IV over 1 hour. Infusion pump, the actual pharmacy sent you 500 milligrams and 100 mLs of D5W. So basic math tells you that it's 500 divided by 500 multiplied by 100 still comes to 100. So just for those of you who are visual, let's see here, I'm going to erase this. So 500 is what I want. 500 is what the pharmacy sent me, and they sent it in 500 mLs or in 100 mLs, which comes to 100 mLs per hour. Simple as that. Now for number 3, it is telling you, let's see here, aminocarproic acid, or Amicar, 24 grams over 24 hours with an infusion pump. The actual pharmacy sent you 24 grams and 1,000 mLs. So 24 divided by 24 times 1,000 is is 1,000 mLs, right? I mean, you have an order of 24 grams, they sent you 24 grams, they just happen to put it in a 1,000 ml bag. What the next question asks you is what is the rate, which is 1,000. Now it's asking over a 24-hour period. So what we're going to do is we're going to divide 1,000 by 24, which comes to 41.666. Now it comes up with 41.6666666667. So what we're going to do is 41.66. We know that this is going to turn into a 7, which then turns this into 4.7. Because again, there is no drip factor. It's actually a pump. We're able to do tenths of a drip. It's actually going to be 41.7 mLs per hour. And let's see here, I think you kind of get the idea. So again, number 4, 10 divided by 125, they sent you 100 mLs in a bag. It's basically what it is per hour. So it's actually going to be mLs per hour. Now going down to the next one, the next page, which is I think it's 268. Let's see here. Yes, 268. What they've now done is they're actually now telling you that the order is for lidocaine 1 milligram per minute. The pharmacy actually sent you 2 grams and 250 mLs and D5W with an infusion pump. So they're actually telling you that's not gravity, it's actually being a pump. Now, for those of you who don't actually know about lidocaine, lidocaine is a medication as a vasodilator for MI patients. This is such a potent drug that you would generally not give it more than 1 milligram per minute, and it's going to be a very slow factor. So if I can find my notes, where I did my math, so it can make it easier for you guys. So for, let's see here, page number 2, number 1, the order is for 1 milligram. Unfortunately, the pharmacy actually sent you 2 grams. So what you're going to do is you're going to convert either the 1 milligram to grams or convert the 2 grams into milligrams. So let's see here. I did the conversion based on the 1 milligram converting into grams. So get my little trusty whiteboard out here. So I did 0.001 divided by 2, which gave me 0.125. Let's see, I take that back. Times 250 equals 0.125. And then, of course, you're going to multiply that by 60 because we actually want to find out per hour, and it's 7.5 mLs per hour. And we don't round because they actually told you they actually have an infusion pump, and there is no drip factor, so I don't have to worry about trying to eyeball a fractionized drip, which I can't do because I'm not Superman. So let's see else what we got. Then number 2, let's see here. Labetalol, 2 milligrams per minute IV, and then they sent you labetalol 300 milligrams in 300 mLs with D5W for an infusion pump. So for number 2, what I did is, let's see here. Number 2, I did 2 divided by 300 times 300 times 60 for the minutes. That gave me 120 mLs per hour, which is going to answer number A, which is the drip rate, which is 125 mLs per hour. And then it's asking now how many hours will the IV run. So what I actually do is you take the 120, put it into the 300. So 300 divided by 120 gives me 2.5. Now, see, 2 hours, so it's 2.5 was the amount it'll actually last, but it's going to be 2 hours and 30 minutes. Now, this is what I actually would want you to do because this makes it a little bit easier. If you actually have 2.5, subtract the whole number first, which then gives you 0.5. Multiply that by 60, which goes from seconds to minutes, and it actually puts you at 30. So times this by 60, and you get 30. Does that make sense? If you subtract the whole number first, if this actually had, let's say that this was 2.566667.8 for the sake of math. If that's the way it actually turned out, subtracting this whole number leaves this long number behind. You don't have to worry about doing anything with it. Just multiply that by 60. So let's just try that out. So let's see here, 2.5, 1, 2, 3, 4, 7, 8. So we've got 2.566667.8. Subtract the whole number. It gives me 0.5666678. Multiply that by 60. That actually gives me 34 minutes. If I would have rounded this, and this actually gave me 2.6, that actually gives me a higher number. It's not good enough. So, or it's not close enough, I should say. So if you have 2.6 minus the whole number, which gives me 0.6, multiply that by 60, I actually got 36. That's actually not right. Now, in the real world, nobody cares. But there is a difference between 34 minutes and 36. So if you want to be correct, do not round any of your answers until the end. If you want to hold on to all those numbers after the decimal point, just subtract the whole number. That will leave your calculator with the 0.566678. Then multiply by 60, multiply by 30, multiply whatever you need to do. It'll make you much more accurate. All right, so moving on to the third page. What we have here is dopamine double strength 100 mics per minute IV, and what they sent you was 800 milligrams and 250 mLs of D5W. So for this one, I actually converted the micrograms, and let's see here, my trusty whiteboard. And I have 0.8 divided by 800 times 250 times 60 because we want it for the whole hour, and I actually got 15 mLs. And then for number 2, Let's see here, Levofed, 12 mics a minute. What they sent you is 4 milligrams and 250 mLs of D5W. So what we are going to do is the same concept. And I got, let's see here, 0.012 divided by 4 times 250 times 60 is 45 mLs per hour. Easy enough. And then for number 3, and the reason why I wanted to do at least a couple of these is because this one actually is 5 mics per kilogram per minute. The actual patient weighs 220 pounds, which 220 divided by 2.2 comes to 100 kilograms. So now at this point you've got 5 mics per 100 kilograms per minute. What they actually sent you was 1 gram and 250 ml. So I'm going to convert the micrograms into grams. And what I ended up getting, let's see here. Let's see here, 0.0005 divided by 1 times 250, which is the volume, which gave me 0.125 times 60, because I want it to be in an hour, and I am getting 7.5 mLs per hour. What I didn't explain was how I got that was I actually multiplied the 5 times the 100 kilograms times the 60. So that way that, you know, I really just kind of convert, I just kind of did all the math in this, first. So let's see here, I did 5 mics per 100 times 60, and at that point you divide by 1 and multiply by 250. So same difference. All right, and let's see here, I also did number 4. It's 7 mics per kilogram per minute. They actually told you the patient weighs 70 kilograms. What they sent you was 500 milligrams and 250 mLs of D5W. So for number 4, same concept. Let's see here, I did 7 mics times 70 times 60. So I ended up getting 0.07 times 70 times 60 divided by 500 times my volume, which is what they sent me, and I ended up getting 14.7 mLs per hour. All right, and I don't round because of the fact that, like I said, it's an infusion pump. I didn't give any drip rate, so there's no point of actually rounding. All right, well, if you have any questions, let me know. Like I said, I just want to go over these real quick because I think this will save a lot of class time for those of you who, like I said, if you follow the volume or the formula for it, I think that you'll be pretty good. I think the biggest problem for me was really that conversion, remembering, okay, so I'm converting mics to milligrams or mics to grams and trying to move the zeros around and stuff. But other than that, like I said, I think if you follow the formula pretty well, I think that you'll be able to get through it. And again, these questions, similar questions will actually be on your test for test 1 and test 2. So he said the biggest thing that people have a problem with is really the rounding. Again, don't round until the end. Multiply all your stuff, divide all your stuff out, and then, like I said, at the very end, if I don't give you a drip factor, there's no point of rounding. You only have to go to the nearest tenth. So, all right, well, let me know if you guys have any questions, and we'll go from there.